Hi, we are continuing the EC cases in street fighting mathematics. So, in this problem, in this example, we are supposed to calculate the area of ellipse. Okay, so the ellipse having a major axis of length A and minor axis of length B. Okay, a semi-major axis and semi-minor axis length. Okay, so now what is the area? Okay, here 5 options are given and we need to calculate what is it. Okay, so the mathematical rigorous procedure, which is basically using calculus, and then you need to do the double integration and you need to calculate the right answer. But we are going to go in a street fighting way. So how to do that? So let's use our first tool, which is dimension analysis. Okay, so what is the what is the dimension of A, which is length? Okay, the dimension of A is length and the dimension of B is length. So the dimension of area is length square. Okay, so now let's see what are the things which pass this dimension analysis test. Okay, so if you see the dimension of this quantity, which is length cube, okay, not length square, so we can ignore this option. Okay, fine. What about here? Yeah, this passed the test. And what about here? Even this passed the test, this passed the test. All things are passed the tests, okay, except the first one. Okay, fine. So that's about the dimensional analysis. So we couldn't conclude a single answer. So let's go for the EC case. Okay, maybe I'll change the color. The blue color is nice. Okay, so the EC case is, let's see, let me make B is equal to 0. So what will happen if B is equal to 0? This length gets reduced and it will become a single line, just a line, right? The ellipse will collapse into a line. And in that case, what is the area of the ellipse? The area of the ellipse is 0. Okay, so this should give A to be 0. Now let's see whether this EC case is being obeyed by these options. Okay, so if you see option B, when B is 0, this term will go to 0, the second term, but the first term will remain, right? So as a result, the solution will not give 0, so we can ignore this option. How about here? When B is 0, this option actually gives infinite, right? So the answer is 0, but it's giving infinite. So this is also not a right answer. Okay. Now look at here. When B is 0, this is also 0. How about here? When B is 0, this is also 0. Okay. Now let me put A is equal to 0. That is also going to give the area to be 0. And if you check D and E, even there, those two options passing this EC case as well. Okay, fine. So in that case, we have to come up with one more EC case to distinguish or uncheck whether these options getting passed or not. Okay, so the third EC case is, what if A is equal to B? Okay, if A is equal to B, then this ellipse will become a circle. Okay, and what is the area of the circle? The area of the circle is pi A square, right? So that's the solution. Now let's compare the options here. So when A is equal to B, then this option will become 2a square, and this option will become pi a square. Okay, so from this we can say that the option D doesn't pass this test, so the option E is the right answer. So that's how we have to use this easy case test. Okay, right. So now here there are some problems. So the first problem says that so now it's an easy case. We have easily identified the answer, but why don't you go mathematically rigorous way and try to identify whether A is really pi AB. Okay, just try it. So if you try, only then you will appreciate this technique. Okay, right. The second problem is inventing a passing candidate. Okay, so could you come up with a candidate, okay, an option basically, which will invent a second candidate for the area that has correct dimension and passes these three cases. Can you come up with an option which passes these three cases as well as the correct dimension? Okay, so give a try. Okay, and then the third one is like ellipse. Could you identify a volume of ellipsoid? So here we haven't given options, but you know the volume of sphere. So from there, could you kind of extrapolate or extend the solution to the solution of the volume of ellipsoid? Okay, where A and A, B and C are the principal radii of this ellipsoid. Okay, so give a try, and then we will meet again with another topic in the easy case itself. Thank you.